Hello, geometry students. Today we're going to be going over the Unit 5 workbook. It's going over the entire Unit 5 packet, except the activity and the review. Those will be done in separate videos. So if you can, get out your packet, open it up to the very beginning, and we'll go ahead and get started. Let me share my screen with you guys, and we'll get to that there. Okay. So the first thing I want to point out is that this unit is going to go over something called the law of sines and the law of cosines. So if you remember from Unit 4, there was a part in that unit that talked about sine and cosine. If you remember that material well, then that'll help you very much in this unit here. Okay. The one thing also I want to point out is if you look on page 2 here, so right in the beginning, 5-1, law of sines is what we're going to go over. I want you to get used to the way this triangle looks. So notice that the angles, the angle measures, they all have capital letters. So notice capital A, B, C, those represent the angles. Whereas the lowercase a, b, c, those are the sides. So that's generally how triangles are going to be labeled throughout this whole unit, and generally how they'll be labeled not just here, but in other textbooks. You'll see basically the angles get capital letters and the sides get lowercase letters. Another thing I want to point out is the orientation of the letters. So notice like capital A is in this left corner here. And notice lowercase a is opposite from that. So the angle and the side opposite from it, they share the same letter, but the angle is capital, the side is lowercase. And you can see capital C with lowercase c on the opposite, and then capital B with lowercase b opposite. So that's kind of key in the way that triangles are labeled, is that the same letter is opposite from itself, right? Just capital, lowercase. Okay. Now let's take a look at this law of sines here. Basically what it says is sine of A divided by A equals sine of B over B, sine of C over C. Now this will make sense in a minute, but basically what this allows us to do is that if we have any two angles and one side length, we could find another side length. Or if we have two side lengths and one angle, we can find the other missing angle. What's key is that notice it's A over A, B over B, C over C. So it's sine of the angle divided by the side opposite from that angle. Sine of the angle divided by the side of the triangle that's opposite from that angle. Okay, so same letters here. So it's always the opposite from there, A to A, B to B, C to C. So the angle over the side opposite from it. The angle, sine of the angle divided by the side opposite from it, so on. Okay, now let me show you how this is used. So they have this example here where there's a missing side length. They label it with an X. What I want you to do is, and I've said this before in other videos, but whatever I write, you should write. Okay, so even though it shows all the steps here, we're going to go ahead and write most of the steps. I want you to rewrite the steps underneath here. Okay, and we're going to set up how to do this. So first, let's look at what we have and what we're missing. So we have one side length, but we're missing the other side length. And we have two angles. And what's key is knowing the opposites. So for example, you could see in this one, opposite from this 38 degrees, angle C, opposite from that is this X here. Okay, so you can see that there. So that's kind of key, is being able to recognize the angle and the side opposite from it. Similarly, this 63 degrees, the opposite from that is this 24. So we could set up our law of sines. So it'll be like sine. And now I'm going to go ahead and put the 63 here. So sine of 63 over the side that's opposite from that. So that's 24. equals. Now we want to set up the other angle with side. So this would be sine of 38 over x. Okay. Hope that makes sense how that's set up. So again, it's the angle divided by the side opposite from it, the angle divided by the side that's opposite from it. Now from here, we can solve for x by what we would do is cross multiply. So it'd be sine of 63 times x. So across this proportion like that. So cross multiply. So sine of 63 times the x. I'm going to go and put the x in front. Okay, these are multiplied. Equals. And then we do 24 times sine of 38. Okay. Now with your calculator, let's go ahead and calculate what this is. So make sure your calculator's in degrees, but let's go ahead and do this right side first. So it'll be 24 times sine of 38. 24 times sine 38. Again, make sure your calculator is in degrees, not radians. Okay, so here we got 14, and generally I'll go 3 decimal places along the way. So 7, 7, it says 7758, so that 8 would round the 5 up to a 6. So 776. Here on the left side, it would be x times sine of 63. So we can just do sine of 63, and that'll be x times, and this will be point, sine of 63 gave me 0.891. Okay. Now to get x by itself, we want to divide by this 0.891. Cancels that. Divide by 0.891. Divide this, so that'll give us x equals, and then we just divide that there. So 14.776 divided by 0.891 gave me 16 point, and let's just go 2 decimal places on the answer, 58. So generally what I like to do is I'll do at least 3 decimal places for each step along the way, and then 2 decimal places for my answer. That helps reduce rounding error when I'm only doing 2 decimal places. But anyway, that tells us the side length. So we just found the side length here. So the length from A to B is now 16.58. So now we know that, 16.58. And that's how it's done. Pretty simple. Let's go ahead and do this second example here. Actually, let's just skip on down to this example here. So I want you to go and look at this example too, but we're going to go and work on this quick check here. Okay. And again, you don't necessarily need to fill in these blanks. If you just do all the work below here and just kind of copy what I do, that'll be enough. So one thing I want to look at is, how do I set up the law of sines? So I notice I have this angle C here is 83 degrees. I also have this angle A here is 61 degrees. I don't know angle B yet. But I do know I could set up this. So sine of A, 61 degrees, over the side opposite, that's 14. So that's sine of 61 over 14. Okay, again, because these are opposite angle inside here, I know that information there. Now, I need to involve x in this. And so x is a side length, and that will go down here. But I need to know what's the angle opposite from it. Well, that's angle B. So I need to figure out what this angle is here in order to fill this in. So it's going to be sine of, and then what's angle B? Well, we don't know that yet, but we can figure it out. Now, the way we're going to figure it out is the fact that in a triangle, and hopefully you remember this from last unit or the units we've done before, we've talked about this before, but in a triangle, the three angles within a triangle, they always add up to 180 degrees. So if I have two of the angles in here, I automatically know the third because I know they have to add up to 180. Okay, so if I know two angles, I automatically know the third because they have to add up to 180. So I can go ahead and figure that out. So I can do 83 plus 61, subtract that from 180, and I get that angle B is 36 degrees. And of course, you could always check because these three angles in here should add up to 180. So you know you did it correct if they add up to 180. So now we can set it up easily. Sine of 36 over x. Okay. Now it's the same as what we did in the first example here. Cross multiply and divide. So let's go ahead and do that. 14 times sine of 36 again, multiplying across the proportion, equals, and then you do sine of 61 times x. Here I put the x at the end. You could put the x in the front. Either way, that doesn't matter. So 14 times sine of 36, sine 36. This gives me 8.229. If I'm rounding correctly, 8.229. So make sure you're rounding correctly. You should get that if you're rounding to a third decimal place. Sine of 61. So on the right side, we have x times, and this is 0.875. To get x by itself, we're going to divide by 0.875, both sides of the equation. To get x by itself. So that'll give us that x equals, and then over here, let's go ahead and do that. So that's 8.229 divided by my previous answer, 9.41. Okay, again, that gives me the distance here. So that's the distance from A to C, 9.41. Okay, I hope that makes sense. Now, with that being said, we'll come back and do this question later, this quick check on page 4. But what I want you to do before we do that, I want you to go ahead and try question 1 and 2 here. Okay, question 1 and 2 on page 5, they're exactly like what we just did. So setting up the law of sines, setting up the law of sines just like we did in the last 2 problems. Okay. So if you have trouble, try to look back at those examples and try to follow. You can rewind the video and follow along. These are just with different numbers. Okay. Now again, both of these are kind of like the second example where we're going to have to find the missing angle here. But again, remember, to find that missing angle, the 3 angles inside should add up to 180. So you go and find that first. Okay. It's never a bad idea to just figure out, okay, what can I find out easily in geometry? What measurements can I easily figure out? And then you have more kind of pieces of the puzzle to work with. But in this one, the first thing you want to do is find the missing side length or missing angle measure here. And you do that by finding out the 3 angles should up to 180. Same thing with this one. And then set up the law of sines, see if you can figure them out. Okay. Okay. Now, what else can law of sines be used for? So let's go ahead and do this quick check here. So if I wanted to find this missing angle, so here an angle is missing. This angle measure is unknown. So how do I find that missing angle measure? Well, I could use law of sines once again to help us with this. So in this case, we're going to have sine of x. So here, the angle measure is unknown. So that's sine of the unknown, sine of x over, should it be over 14 or should it be over 21? Well, it should be over 14 because that's opposite from the x, see? In law of sines, you always use the opposite there. Equals. And then the other fraction in this proportion will be sine of 80 over 21. So sine of 80 over 21. Again, making sure you got the opposites there, okay? So now what we could do, like before, cross multiply. So it'll be 14 times sine of 80. Okay, again, multiplying across the proportion. So 14 times sine of 80 equals, and then cross multiply this way as well. So that'd be 21 times sine of x. Okay, so this left side is easy. We should know how to do that. Just put in the calculator, 14 times sine of 80. And that'll give you 13.787. Over here, I'm just going to rewrite this because I can't put sine of x in the calculator. It won't calculate that for me because x is unknown so far. So I'll just rewrite it like this. Now, if I'm trying to get x by itself, what I would like to do is get rid of this 21. So notice these are multiplied here, 21 times sine x. So in order to get rid of this 21, the first thing I'm going to do is divide by 21 both sides. So divide by 21 both sides of the equation. Now my left side says 0.657. And my right side is still sine of x. Now you may notice I left a little bit of space here between the equal sign and the sign. This equal sign and this sign, I left a little bit of gap there. I did that on purpose because we're going to put something there. Now, if you remember from the previous unit, Unit 4, in order to cancel out a trig function like sine, what you'd want to do is a sine inverse. Okay. Now, this is going to come into play later on in the unit as well. So keep this in mind. In order to cancel a sine, you're going to need sine inverse. And to cancel out a cosine, you need a cosine inverse. Hopefully you remember that from the last unit. But anyway, so what we're going to do is sine inverse of sine of x. So it looks like that. So it looks like sine, and it has like a power to the -1. So sine inverse is how you read that. So sine inverse of sine of x. Similarly, whatever you do on the right side, since we put a sine inverse on the right side, you have to do a sine inverse on the left side as well. Again, whatever you do on one side of the equation, you do the exact same thing on the other. Now, what happens with sine and sine inverse? Well, they cancel each other. That's the point. When you cancel out sine and sine inverse, that's the point. So that's how you cancel out a trig function, is with a inverse trig function. So that leaves us with just x on the right side. Again, hopefully you remember this from last unit. Now, in our calculators, we want to do sine inverse of 0.657. Now, usually on this calculator and on most calculators, you have to press like the second button. Hopefully you can see that, the second button. And then when you press sine, it actually gives you sine inverse. So I'm going to press second. And then when I press sine, it gives me sine inverse. Hopefully you can see that there. And then I'm going to put in 0.657. And I think most calculators operate that way, where you have to press second, and then when you press the whichever trig function, it gives you the inverse. So this will give us 41.07. And this is in degrees. So it says, if it ever says round to the nearest degree, then we would just say 41. 41 degrees. Here I rounded to the nearest 100th of a degree. But hopefully that makes sense there. So that means the measure of this angle here is 41.07 degrees. That's how you figure that out. Okay, so that's how you find the missing angle, like that. So with that in mind, I want you to go ahead and try to do the two problems on page 6. So both of these are just like the one we just finished. So both of these, you're finding a missing angle using the law of sines. Okay, so see if you can figure that out for each of these. For this one, it would be sine of x over 14, because that's what's opposite from this angle, equals sine of 100 over 23. Okay. This one down here is going to be set up very similarly. So see if you can finish this one up here. You're going to have to use sine inverse for both of these. Whenever you're looking for an angle, you're going to have to use one of the sine inverse in these cases. Okay, so give these both a try. Do your best. You have the example that we just did together, as well as you can see there's an example up here as well. Okay, let's move along. So let's go ahead and go to page 7. Question 5 here says, a truck driver is running out of gas. His dial says that he can travel exactly 10 miles. He can deliver his shipment to one of two places, Max's Auto Goods or Jimmy's Car Supply, which are about 10 miles apart from each other. Using the image below, determine which store he can make it to with the amount of gas he has left in his truck. So he's only got 10 miles of distance that he could travel. And here's the basic picture. So the truck driver is here, and he's basically asking, okay, do I have enough gas to go to Jimmy's Car Supply? Or do I have enough gas to go to Max's Auto Goods? Which one should I go to? That's the truck driver is trying to figure that out. Okay. But he knows that these two places down here are 10 miles apart. So that's where that 10 comes from. And he also knows these angles here. So this has a 48-degree angle and a 72-degree angle. Okay. So what we're going to do is we're going to find each of these variables, A and B. We're going to find each of them by using law of sines. So we're basically going to have to do law of sines twice. Once to help us find A, and then once to help us find B. Okay. You may also notice, hey, can we figure out this angle right here where the truck driver is? Yes, we can figure out that angle because we have these two angles down here, the 48-degree and the 72-degree, and we're missing this one. So the three angles together should add to 180. So again, I can add these two together and then subtract from 180 to figure out these the top angle. So that'll give us a 60-degree angle. Okay. Again, the angles should add to 180. So that's how you know you did it correctly. Now let's go ahead and use law of sines to help us find A. So again, A would be the distance to Jimmy. You see that? From the truck driver to Jimmy. So we're going to help us find A. Let's do that first. So let's set it up. So it'd be sine of, and I'm going to go ahead and use the 60 and 10 here. So sine of the 60-degree angle over 10. Notice that 60 is opposite from 10, so that's why it goes like that. Equals. Now, if I'm trying to find A, that means this side length goes down here, and the angle opposite from it, sine of 48, will go on top. So here's how you set up for A. And now it's very similar to the first two examples we did, the one where you're finding a missing side length. That's exactly what we're doing here. So I'll go ahead and work out this with you. So again, cross multiply. So it'll be 10 times sine of 48 equals, and it'll be A times sine of 60. Okay, hope that makes sense so far. So what we're going to do is let's go ahead and multiply this on our calculator. 10 times sine of 48. So that's 7.431 equals. On the right side, I'll just do sine of 60. So that gives me 0.866. So I've got A times 0.866. Now to help us get A by itself, we're going to divide by 0.866. And this will give us the distance between the truck driver and Jimmy. So 7.431 divided by my previous answer gives me that A equals 8.58. So that gives me the distance here, 8.58. Okay, I hope that makes sense. So can the truck driver drive to Jimmy's? Well, yes, because he has a max distance of 10 miles, right? It says he could travel 10 miles. So he can definitely make it from where he's at right now to Jimmy because that's only 8.58 miles away. Okay. Well, can he make it to Max's? Well, maybe. How would we set up for him to go to Max? Well, let's set that up. So again, it would be sine of 60 over 10. So since it's in the same triangle, we could still use this sine of 60 over 10, same fraction. Sine of 60 over 10. Now, if I'm trying to find this length B, well, we're going to use sine of 72 because that's opposite from it. Okay, again, the key is what's opposite from that side, which is the 72 degrees. So that's sine of 72 over B. Okay. Now, what I want you to do, what we're going to do is cross multiply, just like we did up here. So cross multiply, 10 times sine of 72 equals, and on the right side, B times sine of 60. Okay, 10 times sine of 72. Whoops, I put in 75, 72. 9.511 equals, on the right side, B times sine of 60. So I'll just do sine of 60, 0.866. We can remember that from last time. So it's B times 0.866. Again, to get B by itself, we divide by 0.866. So I give us that B equals 10.98. So he can only go 10 miles. So can he drive? So this is again 10.98. So can the truck driver, if he wanted to, can he go to Max's? Well, no, because he can only drive at most 10 miles. He can only drive that distance, 10 miles. So this is farther than 10 miles. It's almost 11 miles. So he won't be able to make that distance to Max's. He will only be able to go to Jimmy's. So I want you to write in a complete sentence where he should go, all right? Hopefully that makes sense. So you should be writing, the truck driver will be able to drive to Jimmy's car supply, but he will not be able to drive to Max's Auto Goods. Okay. And that's the entire lesson for the law of sines. Now let's go ahead and go on to, I talked about earlier, the law of cosines. So the law of cosines, you could see the triangle is written just like we saw for the other triangles, that the angle and the side length opposite from it, they have the same letter, right? C and C. A is opposite from lowercase a. Uppercase B is opposite from lowercase b. And you can see it has these three different ways to write the law of cosines. But I don't want you to like get confused or like have to try to memorize all three of these. The main thing I want you to see is that, and most textbooks only offer this version right here. So they only offer this one that says C equals, C squared equals. Now, these are all the same formula is what I want you to see. I don't want you to think, oh, I have to memorize these three formulas. I just need you to memorize that these are all the same. And the main key thing is that whatever letter is in the front is the same that goes in the cosine over here, okay? Notice it's just lowercase with capital, okay? Okay, so notice whatever side length is here, it'll be the angle opposite from it that'll go inside the cosine. Now, notice there's also no other capitals in this formula, right? The C right here in the front is lowercase. The A is lowercase. The B is lowercase. Here there's a 2 times A times B. Well, those A and B, they're both lowercase too. The only capital goes inside the cosine. So the only capital, the only angle in the formula will go inside the cosine. Okay. Now, I know this formula looks a bit more complicated than the other one, but it'll make sense and it'll be clear what to do with just an example or two. Okay. So don't be too alarmed. I want you to go and fill in the blanks of this thing, these blanks right here. And basically, you're just going to copy from up here. So for the b squared, this needs to be an a squared right here, right? And finish copying the rest from these. So first thing, let's go over this example right here. Example 1, finding a missing side. So how can we use the law of cosines to help us find a missing side? The one thing I want to really emphasize here when we're finding a missing side is that the side we're looking for will go on the left side of the equation. So if you're looking for a side length, that'll go on the left side of the equation. And the angle opposite from that will go inside the cosine. So here we would say, since we're missing this side length, A is what we're trying to find here, right? It says find side A. So since we're trying to find a side length, this side length that we're trying to find, that'll go on the left side of the equation. That's what's key. So in our case, that's A squared. Now, in order to use law of cosines, they have to give you the other two sides. So they have to give you the other two sides. So since we're using these other two sides, that's what goes in the next part. So these both get squared. Okay. Notice the formulas all kind of say that there's one side length here, and then the other two side lengths are squared also, but they're on the other side of the equation, right? So I'll have the side you're missing on the left side, and then the two sides that they give you will be on the right. And then minus 2 times, and then notice it's the same two side lengths that are here, right? You can see that there. See, it says 2 times A times B, and then here it says A squared and B squared. So whatever two side lengths you put here for the A and the B here, those will be the same as what you put right there. So in our case, that's 12 and 19. So that'll be 2 times 12 times 19. and then times cosine of, and then this goes the angle that's opposite from the side you were looking for. So in our case, this is the angle that's opposite from the side we're looking for. So that's what will go in here. And that's how you set it up. So with these problems, I would say the hardest part is just setting it up. Once you've set it up correctly, then it's just a matter of putting it into the calculator. So let's go ahead and start working this out. So this would be a squared equals, and then you do 12 squared, so that means 12 times 12, that's 144. Plus, and then you do 19 squared, so 19 squared, I believe that's, I'm not sure what that is. 19 times 19, 361. Okay. Then we're going to go ahead and put all this in the calculator at once. So it'll be minus, and I'm going to put in the calculator 2 times 12 times 19 times cosine 55. So 2 times 12 times 19 times cosine of 55. So that gives me 261.55. 261.55. And again, I got that by putting this entire thing down here. This whole thing into the calculator gives me that. So now on the right side, let's go and add these together. So if we do 144 plus 361 minus 261.55. 144 plus 361 minus 261.55. This gives me that a squared equals, and then on the right side, we got 243.55. Or sorry, 0.45. Now, I hope you remember from units before, or maybe from algebra, in order to get rid of the squared, you have to square root both sides of the equation. So in order to get rid of the squared, square root. So since I have the squared and the square root together here on the left side, those just cancel. So that leaves me with a just by itself. The square and the square root cancel. On the right side, let's go and square root that. And you should get 15.60. Now, what did that just tell me? What did I just find? I just found this missing side length. So now I know this missing side length A is 15.60. I hope that makes sense. I hope you're able to follow along. We'll go over another example. Let's actually skip this quick check example. We'll come back to it because this one's a little bit different. But we're going to go ahead and do one more example. And actually, let's probably do two more examples because I know this formula is a little more complicated. So let's go ahead and go to this question on page 10. It says, use the law of cosines to find the missing side length AC. So the distance from A to C, that's what we're trying to find. I'm just going to go and put an X there. If you choose to put a lowercase b there, that's fine too. I'm just going to put an X. That's fine. Now what's key is when we set it up, if you're missing a side length, that's what goes on the left side of the equation. So we're going to go and put that first. So here it's x squared equals. Now the other two side lengths, those what go next. So that would be 16 squared plus 30, plus 20. I'm going to go ahead and erase that. Try again. Plus 23 squared minus 2 times 16 times 23 times cosine, and again we use the angle opposite from the side we're trying to find. So that's going to be sine of 90 in our, or sorry, cosine 90 in our case. Okay, so let's go and work this out. So that'll be x squared equals 16 squared. I believe that's 256. Yep, 256. Plus 23 squared. That's 529. Minus, and I'm going to go and throw in the calculator this whole thing. So it'll be 2 times 16 times 23 times cosine 90. 2 times 16 times 23 times cosine 90. Now, you should get 0 here, 0. And the reason why is because cosine of 90 is 0. So 2 times 16 times 23 times 0, well, that'll just give you 0. So that'll give us x squared equals, and then we can just add these together. So 256 plus 529, 785. The minus 0 doesn't do anything. Square root that. And we should get that x equals, and it says round to the nearest tenth. So that means the first decimal place. So round to the nearest first decimal place, that's 28. The first decimal place is a 0 and it doesn't round up. And that's how you find there, like that. Again, square rooted both sides here. The square root to cancel the square. And that gives you the length of AC, just like that. Let's do one more example. So question 2 here, it says use the law of cosines to find the length of BC to the nearest tenth. Okay, so BC, that's the length we don't know. I'm just going to go and put an X there. And let's go ahead and set it up. So again, if I'm missing a side length, that's what goes on the left. So that's going to be x squared equals, and the other two side lengths are the one what comes next. It doesn't matter the order, by the way. So you could do the 8 first or the 16 first. It doesn't matter. So I'm just going to go and put the 8 first. So 8 squared plus 16 squared minus 2 times 8 times 16 times cosine of, well, what do I put here? Well, I want to use the angle that's opposite from this side length. So which angle's opposite from x? Well, that's A over here. But I don't know this angle. It doesn't tell me what angle A is, does it? So how do we find that angle A there? Well, hopefully you remember, hopefully you're able to figure it out. But if they give you two angles, you could always find the third one by remembering the three angles should add to 180. So in any triangle, the three angles inside will add to 180 degrees. So I've got a 30-degree angle plus a 95-degree angle. Subtract that from 180, and I get that angle A here is 55 degrees. So now that I know that this is 55, now I know that 55 goes here. Okay. So again, if you're missing that angle that you need, you might want to look, okay, can I figure out that angle by noticing that the three angles should add up to 180 and go from there. All right. From here, it's very similar to what we did in the last problem. So here we go. I have x squared equals, then 8 squared, that's 64, because that's 8 times 8, plus 16 squared, that's 256, minus, and I'm going to go and throw this whole thing in the calculator at once. So 2 times 8 times 16 times cosine 55. 2 times 8 times 16 times cosine of 55. Okay, make sure you're putting in cosine 55. So that should give you 146.836. Okay, again, since it says to the nearest tenth, that's the first decimal place, but usually I'll go at least 3 decimal places in the steps so that the rounding error is less at the end. Okay, but when we get to the end, we'll just do the first decimal place. So let's go and add these together. So we got 64 plus 256 minus 146.836. Okay, that'll give us that x squared equals 173.164. Now, how do we get rid of this squared here? What's our last step to get rid of the squared? Hopefully you remember, you square root both sides of the equation. That'll give you that x equals, and here's what I'll round to just the first decimal place, the 10th. So I'll get 13.2. And that tells me this side length here, the length from BC is 13.2. Okay. Now with everything I've shown you and how to use this formula, hopefully you'll be able to do questions 3 and 4. Try those on your own. Okay. Both these are very similar. You're just finding the missing side length using the law of cosines, just like how I shown with the last 3 examples. Now, if we go back to question 9, the quick check, or sorry, page 9, there's this quick check that we skipped earlier. Let's go ahead and go back to that now. So with this quick check here, I want you to notice what's different about this problem from the ones we just did. The difference here is that this one, they're asking you to find a missing angle. So here they're asking you to use the law of cosines, but this time we're going to find a missing angle measure. So how do we do that? So how do we find a missing angle measure in this case? Well, let's try setting up our law of cosines. The first thing I want to think about is what's going to go on the left side of the equation. So what's going to go on the left side? Well, I know since I'm trying to find an angle, I know at the end it's going to be like cosine of the angle I'm looking for. So cosine x, because that's the only place in the formula where the angle can go, right? In the formula, that's the only place the angle can go is at the end where the cosine is. Now, if you recall, what goes on the left side of this equation? Well, with the other problems we did, it would be the side we're looking for. But in this case, we have all 3 sides. So which side goes here? Will it be the 12, the 17, or the 19? Well, since x is here, we're going to use the side opposite from it. In this case, the 19 will go over here. Okay, so whichever side is opposite from that angle, that's what's going to go over here. Okay, what's key is that this angle over here and this side over here, they are opposites from each other. That's key. And here you can see they're opposites from each other in this triangle. Now the other 2 side lengths, doesn't matter the order, they go next. So 17 squared plus 12 squared minus 2 times 17 times 12 times cosine of x. All right, so now that we've got that, what do we do next? Well, let's start working out what we can figure out here. So what's 19 squared? 19 squared, that gives us 361 equals, on the right side, we're going to do 17 squared. So that's 289 plus 12 squared, that's 144, minus, now before we would just put all this in the calculator, right? But since we don't know what x is, we can't put this whole thing in the calculator. Let's just go ahead and do the 2 times 17 times 12. We can do that in the calculator though. 2 times 17 times 12. So this would be minus 408. And there's still a cosine x attached to that. Okay, so it's 408 times cosine x. What do we do next? Well, let's see. I'm just going to go and rewrite this 361 equals. Now, what can I combine over here on the right side? Can I combine all of these numbers? Well, no. You can only combine these two constants here. This 408 has a cosine attached to it, so you won't be able to combine it with these others. But you can still combine these two numbers that are just out here adding together. We can add those together. So that's 289 plus 144. So 433. Minus, and I'm just going to rewrite this here. Again, we cannot combine these two things together because this has a cosine x attached to it. So they are not like terms because this has a cosine x attached to it. We cannot combine those. So now let's go ahead and start solving for x. So what I would do to solve for x, what we can do to simplify this equation is go ahead and minus 433 both sides of the equation. So minus 433 minus 433, 361 minus 433. That'll give you negative 72. And on the right side, we have a negative 408 cosine x. Now, you might see, oh, well, we could divide both sides by negative 408. Divide by negative 408, both sides of the equation. That'll give you, and I guess I got more space here. So this is going to be point, and I'll go 3 decimal places, 176 equals, and on the right side, since this cancels, it'll be just left with cosine x. And again, like we saw with sine, I left a little bit of space here. Now, why did I do that? Well, because I want to cancel out this cosine, I'm going to have to use cosine inverse. So cosine inverse to cancel out this cosine here. To cancel out a trig function, you always use the inverse of that trig function. That cancels it. So cosine inverse and cosine, those cancel each other just like that, leaving you with x on the right side. So the cosine inverse, they cancel. X is what remains. Here on the left side, let's go and do cosine inverse of 0.176. And you should get 79.84. And this is in degrees. Because we're finding this x, now we know the measure of this angle. The measure of the angle is 79.84 degrees. Okay. So I know that was pretty complicated, but if you follow the steps and kind of just rewatch that problem and make sure you write everything and understand everything, hopefully each step along the way will make sense. So if you understand each step along the way, that'll help you a lot. So just kind of on this first example, make sure you understand how we got from one step to the next step. How did we get from here to there? Then how did we get from here to there? So on down the entire problem. Once you've got that kind of in your head a little bit, and again, you don't have to memorize all this, just for now, just make sure you understand how we got from one step to the next step. How did we set it up? How did we get here? How did we get here? And just go down the line. Don't worry, we're going to go over another example just like this one. So if we go down to page 12, we can see there's 2 more problems here, and we're going to do one of them. So we're going to go ahead and do this one right here. They both say number 5, but we're going to do this first, number 5. This one says, use the law of cosines to find the measure of angle A to the nearest tenth. So here we're finding the measure of angle A. That's right here. So how do we set this up? Well, we know I'm just going to call this angle, I'm just going to put an X here. But just know that that represents the measure of angle A. So it'll be cosine of X. That'll go over here. So whenever you're finding a missing angle, I like to just put it right in here. The angle always goes in this cosine. When we're using the law of cosines, that's the only place for the angle to go. Now, on the left side of the equation, which of these sides should we put over there? Should it be the 11, the 9, or the 6? Well, it should be the one that's opposite from the angle we're looking for. So in that case, that's the 9. So the 9 goes over here. It's very important that you know which one goes over here, but it's not important which one goes for which on the right side, because it doesn't matter the order on the right side. Just the 11 and the 6 will go here. But make sure you got the correct one to go on the left side. So the 11 and the 6 go on the right side here. So it'll be 11 squared plus 6 squared minus 2 times 11 times 6 times cosine x. Okay, let's start working this out. So what's 9 squared? That means 9 times 9, so that's 81, equals 11 squared, that's 121, plus 6 squared, that's 36, minus 2 times 11 times 6, 132, cosine of x. Here we'll have 81 equals, let's go and add the 121 plus 36, 157. Minus 132 cosine x. What do we want to do next? Well, hopefully you could see that I would subtract 157 on both sides of the equation. 81 minus 157. Negative 76. And on the right side, we have negative 132 cosine x. That's a 3. Doesn't look much like a 3, but it's a 3. Okay. Divide both sides by negative 132. That'll give you that we have 0.576 equals, and on the right side, we have cosine x. Again, to cancel out the cosine, we're going to use cosine inverse. And that cancels out cosine. And then we cosine inverse the other side as well. On the right side, that cancels cosine inverse and cosine. They cancel, leaving us with just x over there. On the left side, let's go and use cosine inverse here on this number. And we get 54.8. Again, round to the nearest tenth. That means the first decimal place. And so there you go. Now we know the measure of that angle. It's a 54.8 degree angle. Okay. So now we've worked out one more example with this. Hopefully, go ahead and try this other question 5. See if you can try this on your own. Here we're trying to find the measure of angle B in this situation. It's the same triangle. It's the same triangle, but it will be a different answer because you're trying to find a different angle. Okay? So with all that, hope that all made sense. and go ahead and finish all the ones that we didn't do together. And then you can go on to the review, see how much of the review you can do on your own. We've covered all the material you need to be able to do the review on your own. So go ahead and give it a try. It's everything that we've already covered. Okay. I've also covered the activity in another video, so you can feel free to watch that video and go over that activity. Okay. Well, with that being said, I will see you next time, and good luck on the rest of the unit and good luck on the tests to come. See ya.